Okay friends, so after discussing the properties of metals and non-metals, I'm just going to give you a quick, recap of them. They are good, metals are good conductors of electricity, they are sonorous, they are ductile, they are malleable, and they are solids. And the same goes for non-metals, but in a reverse manner. And one more, characteristics of them are, in metals, they always lose electrons to be an octet, which we will be studying in the fourth chapter, that is the structure of an atom. And metal always loses electron, but non-metal gains electrons in most of the cases. So this is the difference between both two. And talking about the metalloids, they have the intermediate properties between both metals and non-metals. That means that it can have the property of either metals or non-metals. Same goes for that property, that it can lose an electron or it can gain an electron, depending upon its nature or its type. So this was my explanation for metalloid, and I think you must have understood by now what is a metalloid. A metalloid is a substance which has intermediate properties between the metals and the non-metals, which means that it can have the properties of both metal and non-metal, or either ones, depending upon its nature. So let's go on to compound. So we are on the second type of a pure substance, that is a compound. So, a pure substance that is made by the connection of two or more atoms chemically bonded together. But they are called pure substances because they are chemically combined, and they show different properties from their constituents or the particles from which they are combined, and so they are the pure substances. And whenever you count them, you will count them as one molecule. If I'll say that a sample contains four pure molecules of H2O. So I'm counting them in molecules instead of atoms, because you see, in each of the molecules there would be three atoms, two atoms of hydrogen and one atom of oxygen, because of its chemical combination. So this is compound, a pure substance combined by two atoms. So two or more atoms can be its constituents. In an example of H2O, or if I give you an example of H2SO4, that is hydrochloric acid, or any other acid, or any other compound. It's a pure substance because it's a molecule, and a molecule is a pure substance because it's chemically bonded, and it's chemically bonded because it does not show the property of its constituents. So let's go on, and I think that you might have understood the two types of the pure substances, that is the elements and the compounds. And now I'm going to tell you about mixtures. And so coming on to the impure. Now I'm going to tell you something about the impure types of things, that is a mixture. A mixture is when we mix two particles which have either physically distinct parts or not, but they are not chemically bonded. That means that they show the properties of their constituents. If we take an example of that, you remember the old chalk powder one? Then it would give, it would show the properties of the chalk powder as well as the water. So it is a mixture. And if reading from the book, I would say a mixture is a substance which consists of two or more substances. Which may be elements, compounds, or yes, elements or compounds. and are both mixed together. And it may or may not contain physically distinct parts. In the example of the chalk powder, you could distinct that layer of chalk powder from the layer of the water. And if you just mix them and it's a fresh solution, then you would see the water as white. But in some cases like sugar solution, you cannot just distinct it. You see it even if it's a fresh solution or it's a non-fresh solution, you will see that it's a water. You cannot just distinct out sugar. Oh, this is the layer of sugar, because it has gone into the molecules or the atoms of the water, and so it is mixed with it thoroughly. But the chalk powder could not mix with it thoroughly. As a result, you could see an outlining boundary, and so we can distinct this mixture in two more parts. That is a heterogeneous mixture and a homogeneous mixture. And homogeneous. Sorry. So friends, if you are getting confused where is it in the book, then you can go on to page number. It's on page number 15. What's the solution? But just before this, there is an activity given in which they are distinguishing between homogeneous and heterogeneous mixtures. So, first, before going on to its type, I'm just going to give you every property of a mixture. That is, a substance which consists of two or more substances which may or may not be elements, compounds, are both mixed together in a physical state in any proportion, but not chemically compound. They have variable composition. That means, you can put 2 spoons of sugar inside it, 4 spoons of sugar inside it, or even half a spoon of sugar inside it. That would give you the same solution until you go to on that supersaturated and saturated problem. Till that it will gonna give the same impact. That means it has variable composition. But if we talk about a compound, then in a compound you always have fixed composition. That the hydrogen, only 2 atoms of hydrogen are gonna go in, and only 1 atom of oxygen is gonna go in. It's not that you can put 3 atoms of hydrogen and 98 atoms of oxygen and you're gonna get the same H2O. It does not mean so. So it has fixed composition. And in a mixture it can be variable composition, and depending upon its type of composition only, we have distinguished it between the heterogeneous and the homogeneous one. So to just distinguish these two, primarily I'm going to write that a heterogeneous is non-uniform mixture. These are 2 technical words which I think you won't go inside your mind. So I'm going to explain it into a more simpler words. That means you can have those physically distinct parts. That this is the layer of chalk powder, this is the water, and you can distinguish between 2. But in the case of uniformly mixed mixture, that is the sugar solution, you cannot just distinguish between the sugar and the water. So, it's uniformly mixed. Then going on to the other properties of the mixture is that no new substance is formed. That means if you mix sugar and water, would you get a new type of substance? Many of you might be thinking as, yes, we can get SHO2, but H2O, but it's not possible because they are not chemically combined, and so it's a mixture. In a mixture, no new substance is formed, and they show the properties of their constituents, and so it's a mixture and it's not a compound. So you can, and by now I think that you can easily distinguish between a compound and a mixture. A compound has a fixed composition and a mixture has a variable composition. And so I think I have distinguished between the mixture and the compound and told you about the 2 types of mixtures. The later on part would be discussed in the next video, and I expect you to like my video, subscribe my video, and come on to my channel, that is the Dashing Knowledge channel.